Hi students, we will be moving on with whatever we were studying about the modern periodic table, and I think yesterday I had told you to solve one exercise problem, that is problem 3.1. I hope all of you have solved it and you have got the answer. Okay. They have asked how many elements will be there in the sixth period of the periodic table. So, what did I tell you always to do? Always you have to kind of first of all see how many subshells are there. I had told you this part if you remember. So, I always told you that when you say a certain period, the 6s and 6p orbital will be there, and I had also told you how to get the orbitals which are there other than this. You have 4f and you have 5d. So, these are the sub shells. Then you can have the magnetic quantum numbers, magnetic quantum number. So, in case of this one, in case of the magnetic quantum number, for S you can take it as 0, for F it is -3, -2, -1, 0, +1, +2 and +3, because that is what you have, which is the f orbital. Then for d orbital you have -2, -1, 0, +1 and +2, and for p orbital you have -1, 0 and 1. So, magnetic quantum number you should remember should only depend on what? Should only depend on the L value and nothing else. It should not depend on the n value. So, this will basically tell you the number of orbitals. Number of orbitals. So, what can I say in this case? If it is number of orbitals, here the number of orbital will be 1, here the number of orbital will be 7, here 5 and here 3. So, it just depends on the numbers there, how many are there, that many. So, if I add all these together, I am going to get total number of orbitals to be 16. So, what are the total electrons? Total electrons, or you can say total elements, will be equal to 2 into 16, which is equal to 32. So, as many electrons and protons you are going to add, that many elements are going to be there. Okay. So, I hope you have got the answer. If you have done some mistake or you have not got the answer, please go through this and copy this down. I will give you some time for it. Okay. Just note this down. Write it quickly. Next, we see what are the merits of the periodic table. We have seen all of them. I have mentioned it as and when I was teaching you this. So, what is the merit of the periodic table? In case of the periodic table, the merit would be that first of all, you are having the elements in a regular order, and that order is been understood. The reason is because of what? It is because of the electronic configuration. That was the problem in the case of Mendeleev's periodic table. We did not know the reason why it was a very why that order was there. We know that it is because of the atomic mass, but why atomic mass? There is a periodicity. But here we know the reason for the periodicity is similarity in the electronic configuration. That is why in a certain group the valence electrons, maybe there is inclusion of f orbitals, d orbital, that does not matter, but the s and p orbital, when you go for it, if it has the same thing, you can definitely say that its electronic configuration is same and property remains same. What I mean by that is, when you go for example here the lower elements like thallium, you have introduction of f block and d block in the electronic configuration, but the number of s block and p block electrons will remain one and the same. So, that is what you have to see when you go for S and P block. D block and F block, you do not have to worry, the electronic configuration will be same. So, once the electronic configuration is same, you will see similarities in properties. So, what is the thing? You can tell the reason, and secondly you can predict the properties. You can predict the properties. Now, our periodic table has ended here. I can predict the property which comes below that. I can say it will not be stable, that is for true, okay, that is true. But what I am telling is, if the elements come below this, I can say that it will be a larger element. We will be seeing those properties, but based on the position in the periodic table, I can definitely say what the properties are. Now, this is something which is there in Mendeleev's periodic table also, but the thing is, there were some exceptions. If you see, for tellurium and iodine, for I think argon and potassium, we had that problem, but that problem is completely solved here, and based on this we can definitely guess what the property might be of an element. There might be slightly here and there, but that does not matter to us. Slight variation is fine, but there will not be a big variation. Okay. So, this is one more thing, and other thing which is even better is you have blocks. When I say blocks, I mean S block, we have seen it yesterday, P block, D block and F block. Based on this, we can again say, because it belongs to that certain block, we can say that it will have a certain property. For example, when I talked about S block, I told you that these elements are going to be metals. They can be drawn into wires and sheets, but they can be broken up very easily, right, because it is very soft, we can say at the end of the day. This is soft also, but then later on when we go to D block, we can start saying that the metals become harder. Okay. So, when we say a metal belongs to D block, we can say a metal becomes harder, but at the same time mercury is a liquid. So, when you look at that group, you can say that the next element might also be a liquid, or maybe a soft solid, or a low melting solid, or something like that. Okay. But then the stability has decreased. That is the main problem. After mercury and all, the elements have not been studied that well. That is, below mercury you have something called as copernicium. This is a very unstable element. So, these and all have not been studied. These are all being synthesized by us. So, these blocks will give us an idea about what kind of element it might be, what kind of general property it might possess. Based on what comes before it, after it, above it and below it, we can have an idea. So, this also is one more thing, and the other thing which I told you when I taught you about the periodic table was also this noble gases, positioning of noble gases. What did I tell you when I taught you? I told that because the last electron enters into the p orbital, it belongs to the p block. So, if the last electron had entered into the s orbital, we would have called it s block. If the last electron enters into the d orbital, or what we call as the distinguishing electron, that will be d block, then you are going to have f block. So, based on that, we can definitely say that noble gases are best placed not on the left side of the periodic table, but rather on the right side of the periodic table, because the last electrons enter into p orbital. That is very important. Electronic configuration, you know how to write, and I hope you have answered the other exercise problem also, I think 3.3, where you have to write the general electronic configuration of the valence shell of individual blocks. This I told you yesterday, 1 mark question will come from there, okay, writing the general electronic configuration. So, these are the benefits. What about the drawbacks? Drawbacks, I told you, you have hydrogen and also the lanthanoids and actinoids. This is where we still have a certain drawback, but compared to whatever benefits we have, advantages we have, these drawbacks are relatively fine. Okay. So, this is where we are now regarding the periodic table. Okay. So, this is about the periodic table and how it is developed to what we have now. Okay. So, once we go about the periodic table, I had also yesterday told about something about metals, non-metals and metalloids. So, you have studied about metals, non-metals and metalloids, or mainly maybe metals and non-metals. So, in this case I told you where the metalloids are. I will again mark it. You have silicon, germanium, arsenic, antimony, tellurium, polonium and astatine. This is what we have now. This is how it is represented even in your textbook also. These are the blocks. So, if you have the periodic table in front of you also, it is good. There I think different colorations are given. So, these are what we call as metalloids. Now, this however, if I put a line here, okay, whatever comes on the right side of that zigzag, that is going to be non-metals. Whatever comes on the left of the zigzag, that is going to be metals, and whatever elements are present in the zigzag, these are going to be what we call as metalloids. Okay. Metals, if you remember, have common properties like metals are very good conductors of electricity. They are malleable, they are ductile, you can what to say, beat them into sheets, or you can draw wires from them. All these things you can do. They have luster, they shine. Sorry. So, in case of sodium also, it looks quite dull if you have seen sodium. If not, you can search it in YouTube, you will definitely see how sodium looks. It is a bit dull, but that is because of oxidation on the surface. So, if you cut sodium and immediately see the surface, you will see that it has a shine, a silvery appearance. So, normally metals shine, okay, and you know how good the shine gold has. Okay. So, others will be having normally silvery appearance. Cesium sometimes appears slightly golden. Okay. Normally, the number of valence electrons will be 1, 2 or 3. It can be more than that when you go for D block, but when you go for representative elements and when you have metals, it is 1, 2, 3, sometimes 4 and 5, but removing those electrons are not easy. They generally lose electrons very easily. Okay, metals, that is one of the properties which metals have, they lose electrons very easily. So, this is what generally you have properties of these elements in varied number. Okay, some might lose electrons easily, others might lose electrons with more difficulty. Okay. See, for example, metals generally I told you will react by losing electrons. Gold, you know, it does not react very easily. Does it rust like iron? No. Even then its reactivity is very, very slow. So, what can we say? Its ability to lose electrons is less compared to the other metals, or least you can say, because it is a noble metal. Noble metal means something which does not react very easily, but it has other properties of the metals also. So, that is why it is a metal rather than a non-metal. Elements on the right side are generally non-metals, all of them are non-metals there. So, instead in case of metals where it is an exception that you have liquids and no gases, okay, non-metals, one of the non-metal is here, all others are on that side. So, non-metals can be solid, liquid or gases. They do not conduct electricity, they generally do not have any shine associated with this. Okay. So, it is kind of opposite of that of metals. If metals are very good at losing electrons, non-metals are very good at gaining electrons. Okay. So, that is one of the things which you can distinguish, but in non-metals also there are some elements on the right hand side which we call as the noble gas elements, which do not react at all. That means, they neither gain electron or they lose electron, or it is very difficult, extremely difficult to do that. So, this is what you have as far as non-metals go. Even if solids are present in non-metals, they are going to be brittle. Then you have metalloids. Metalloids have properties in between that of non-metals and metals. They can conduct electricity, say like silicon and germanium, but unlike metals, their conductivity will increase with the increase in temperature. So, these are all things again you will be studying in more detail when you go to even in physics and in solid state in chemistry. Okay. But just know that in case of metalloids, their properties will be in between that of metals and non-metals. So, this is something you have regarding how the elements are present based on what you have in the periodic table in their positions. Okay. So, you can say most of the elements in the periodic table are solids, some of them are gases and very little are liquids. Okay. Cesium I told you low melting solid, gallium is a low melting solid, mercury and bromine are liquids. Okay. But then almost metals other than that whatever I mentioned are solids and remaining are gases. So, that is what you can say. Same way metals are more, non-metals are less and metalloids are even less compared to the non-metals. So, with this I will just say about the classification of elements based on the properties that I talked about, that is metals, non-metals and metalloids. Okay. What else did I say about the metallic nature? In case of metallic nature, it increases down the group and decreases across the period. This is how you have to write. I will tell you something, I have seen this say many students do the mistake, they get confused between group and period. Period is horizontal. So, do not say down the period, horizontal you do not say down. Okay. So, be very careful regarding your wording, because even if you know the concept properly, how you present it matters in the answer sheet. Okay. Many students will tell, no sir, I know that period is horizontal, but that will not work, because when see in your final exam when corrections are done somewhere else, you cannot give such explanations. They will see what is written on the sheet of paper and based on that they will give marks. So, be very careful when you are answering, cement it in your head that period is horizontal and group is vertical. So, when you are saying for period you say across, when you tell for group you say down, do not mix it up. Okay. So, this is what will happen say in case of metallic nature. We will go to a exercise problem which is there in your study material. So, the exercise problem is as follows, you have 3.4, they have given certain elements. Okay. I will just read it out. Considering the elements boron, aluminium, magnesium and potassium. So, what they have asked you to consider: boron, aluminium, magnesium and potassium. So, these are the elements that they have given you. Can you guess the correct order of metallic character or metallic nature? So, we have this rule now. I had told you this in the previous class, increases down the group, decreases across the period. So, they have given us 4 elements now, they do not belong to the same period or the same group. Okay. So, we have to now basically tell 1 or 2 might belong, but not all of them. We have to tell which is more metallic or which is more non-metallic, whichever order we go for. So, now I have the periodic table in front of me, but this is where your memory of periodic table will come in picture when you are in exam. Okay. So, let me just remove that periodic table. So, let me think about it. When I know the elements, I know something, potassium is a alkali metal, correct, it belongs to the first group. We have certain elements that we name for. If it is 16th group, we will call this element as chalcogen, you might hear these terms. Okay. If it is 17th group, we will call it as halogen. If it is first group, we will call it as alkali metals, and if it is second group, we will call it as alkaline earth metals. Okay, so this is what you will have. Noble gases you already know, 18th group. So generally when I say these names, you should be able to understand which group I am talking about. So if I say chalcogen, it is 16th, 17th is halogen, first is alkali metals, second is alkaline earth metals, and 18th group is called as noble gases. Okay. Now in case of this one, you have boron, aluminium, magnesium, potassium. Roughly you should know, and I think you know till element till I think krypton, I think you know. Yes. So in case of this one, where does potassium come? In which period does it come? It comes in the fourth period. Why? Hydrogen, lithium, sodium, potassium. So what can I write? I can write the potassium here. Now magnesium, what kind of element is it? It is alkaline earth metal. Now this is where you have to know that where does it come? Does it come after potassium? No, magnesium comes after sodium. So that means sodium comes above here, correct? Where does magnesium come? Magnesium will come here. So it is above potassium. Okay. What about aluminium? You have sodium, magnesium followed by aluminium. Okay. Then you have boron. Boron comes above aluminium. Okay. Because it is what? Lithium, beryllium, then boron. So this is how you can remember. Or if you have the periodic table in front of you, not a problem, you can cross check what I have written here with the periodic table. So if you go for the periodic table, you have boron the same, aluminium below it, then you have magnesium on the left of it, and potassium again left and below. So what does the rule tell us? Increases down the group. So if you see here, which is the most down compared here? Okay, it is potassium, and on the left side. Why? Because it is decreasing across the period. So that means the maximum metallic nature will be there for potassium. Maximum metallic nature, because metallic nature it increases down. So when you go down, that will be the highest. Then you have to go to the leftmost side to give the maximum one. Okay. Then you go to the upper one, next lower one compared to potassium. You have magnesium and aluminium. Now both belong on the same line, but what does this tell us? It decreases across the period. So if I compare now, across the period it decreases, means magnesium will be more, aluminium will be less. And then the least one will be the one above it. This is called as boron. Okay. So this is how you can write the metallic character. You will get problems like this. Again, you should have a rough idea about where the elements are. One of the best ways to remember and helpful for you to remember is elements down the group. Across the period also you can remember, but down the group will help you because there are similarities in property. So when I say first group, what should you tell? You should say hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. These many you have to know. Then again you go to the next one, you say beryllium, magnesium, calcium, strontium, barium, radium. So each group you have to know what is the element present. Third group, what is there? Scandium, yttrium, then you have lanthanum and actinium. So if you know all the elements there, you will have an idea about which has higher metallic nature, because when you go down the group, the metallic nature will increase. Okay. So this is what you have regarding the exercise problem 3.4. You can note down the answer and what I used to answer that particular exercise problem. Okay, note it down. Here metallic nature decreases. Okay. Next, we study about the periodicity of properties. Again, periodicity means what? There is a repetition of properties. We will study how the property changes gradually and then resets back, almost not exactly to the previous position, but then again goes back to the same pattern. So, that pattern is repeating. We will study about that for various properties exhibited by every element. You know that there are certain physical properties, say like metallic nature that we have seen, non-metallic nature, melting point, boiling point, then energy required to remove electrons, energy liberated when you add electrons, all these things we are going to see, and we will get a rough idea about how these properties vary. Now, again you will be studying some of them, not all of them, in detail when you go to individual groups. I have told you, you have S block, P block, D block, F block chapters coming later on. So, you will have to study this also, but there you will be studying in detail, and you will be studying about some exceptional cases also, wherein it does not follow whatever rules we are telling now. Okay. So, remember one thing, there will be exceptions. So, you should first of all, one of the best ways to study that even later on is that you should first study it in detail, remember which elements follows the pattern. So, if you know which elements follows the pattern, that means the remaining element will not follow the pattern. So, this is some kind of logical way in which you have to memorize. Why? Because there are many groups in the periodic table. If you just memorize each and everything, then it will be a problem. So, first of all you should have an idea where the rules are followed and where you will find exceptions. When we are teaching that in the coming chapters also in detail, we will be telling you the reasons why it is so. Okay, so, do not worry. If there are no specific reasons, or if the reasons are outside of your syllabus, outside of the scope of your studies now, then we will just tell you to memorize. Okay. So, when we say something, please take it to mind. That is what I told, whenever you are studying, especially topics like this, see to it that you have good basics, that is whatever was taught in the previous 2 lessons, so that you can understand this well. Okay. So, one of the first properties that we are going to study is what we call as atomic radius. Now, this is a very important property based on which we can tell how the sizes of the atoms are going to vary. So, atomic radius we are going to study in this case. Now, in case of the atomic radius, it is not only one kind of radius. Okay. There are many kinds of radius for an atom, but what exactly does a radius mean? If I simply speak, if it is a sphere or a circle, I will take the cross section of a sphere here. If this is the center, you know that this distance is called as the radius, or the distance of the radius, or this particular line is called as the radius. So, we need to know what happens, whether the size of the atom goes on, or the radius of the atom goes on increasing when you go across the period, or decreasing when you go down the group, whether it increases or decreases. So, these are all things that we can study based on our understanding. But first of all, how can we measure the atomic radius is the question. Now, when I have drawn this circle, it is fine, but you have studied in the previous chapter, say atomic structure, you do not exactly know where the position of the electron is, and as well as momentum simultaneously and accurately. So, in this case what happens is, generally we consider electron to be like a cloud. Okay, it appears also like a cloud. So, it is not concentrated, it is diffused, it is a spread out phenomena. So, can you anytime exactly find the atomic radius? It is not possible by whatever techniques we have now. Okay. Later advancements we can't say that, but now at this moment it is not possible to find the atomic radius directly. Okay. Of an atom. If I take a single atom and say, okay, I will measure the atomic radius, that is not possible. Generally what they do is, they take it in a bulk, the atom, a solid you take, and you have techniques, say like X-ray crystallography, it is an experimental technique. Okay. These techniques can be generally, this technique can be generally used to find the atomic radius, but the element is taken in bulk. Okay. But then again we cannot find the radius, as I told you, of a single atom. It will be together with other atoms. So, when we say together with other atoms, again how do they come together? When they come together, the mechanism by which or whatever forms is called as a bond. And you know that every element will not form the same kind of bond. For example, when you take one sodium atom and another sodium atom, it cannot form what you call as a covalent bond, whereas when you take chlorine and chlorine, it forms something called as a covalent bond. I will tell you what exactly it is, but you will be studying it in more detail in the coming chapter called as chemical bonding. Okay, I will just give you a rough idea about what these bonds are. Okay. So, some will have something called as metallic bonding, this is in metals, others will have something called as a covalent bonding, and some like noble gases will not form any bond. So, what to do in such a case? Because as I told you, we need atoms to be together in any way to form a kind of idea about the radius. So, let us see how exactly we can understand this. The first kind of radius that we go for is something called as the metallic radius. Okay. What exactly do I mean by metallic radius? In case of metals, what happens is, it is generally made up of this kind of cubes or hexagons or many things like this. Now, I have drawn only 2 cubes. Now, what happens is, this arrangement can continue in 3 dimensions. Okay? That means, you will have one more cube on the left and again and again and again, one more cube on the right, again. So, it will just continue on in solids, and then you have cubes above, below, behind, coming towards you. So, all these cubes will be there. And how will the atoms be present? The atoms will be present like this. Same metal. Okay. So, this is how the atoms will be present. So, if you see, they are in touch with one another. So, these are touching here, you can say almost, and these are ions actually. So, what will happen is, imagine this is sodium. Sodium, you know the electronic configuration, it has electronic configuration of 3s1 and before that neon. So, what will happen is, whatever corresponds to neon will be present here, and you have 3s1, that one electron is free to move anywhere in this structure. Okay. So, what is this called as? This arrangement is called as the lattice. Okay. This is not the only arrangement possible, there are many arrangements, but whatever be the arrangement of atoms, they will be in touch with one another. So, how can we find the atomic radius? I think you can understand how to find when you look at this, right. I will write it separately, separated from that cubic arrangement. So, this is how you can say. Okay. Now, if I take the center of this atom's nucleus, and if I draw this, I get the distance in between it. Now, if this distance is divided by 2, then this will give me what we call as the metallic radius. Metallic radius. So, if I write this as d, then metallic radius is going to be d by 2. Clear? So, this is what we call as the metallic radius. So, it is what? Half the distance in between the 2 nuclei of atoms of the same metal in a lattice, that is basically called as the metallic radius. This is there in page number 94 of your study material. Again, mark it as important, you may get it as a 1 mark question. I hope you understood what. There are many atoms here also, all of them will be in touch with one another of the same element. If I take sodium, all sodium atoms will be there everywhere, say in the corners. You just take half the distance, in between the nuclei of the two atoms, wherein the atoms are present in such contact. Okay. So, this is the definition. So, they have given the example of copper. For copper, this distance is found out to be 256 picometer. Okay. So, if I want the atomic radius of copper, I have to find out the metallic radius. So, metallic radius, what should I do? I should find out 256 divided by 2. So, I will get 128 picometer. Okay. So, this is what is the atomic radius of copper, and this is what I call as metallic radius. But what if your element is not a metal? What will you do? Then we go for one more kind of radius, that is called as covalent radius. Okay. Now, what happens say in case of covalent radius? In case of covalent radius, now when you have studied atomic structure, you have studied about orbitals, correct? S orbital, p orbital, d orbital. What can happen is, I will simply write like this, I will take some s orbital, this can overlap with one more. See, there is a difference in case of metallic as well as covalent radius. In covalent radius, what is happening? In metallic radius, the atoms are touching one another. In covalent radius, they are overlapping. So, that means they are coming even closer compared to that of metallic radius. So, in this case, what will happen is, if it is p orbital, then p orbital can overlap like this. Anyhow, there should be overlapping, not just touching of the orbital. So, such kind of compounds are also formed. So, what do we do? This bond in between them is called as what bond? It is called as the covalent bond. What is it called as? Covalent bond. Clear? So, if I want to write it, I will write it something like this. Again, do not worry about the shape of the orbital. Shape of the orbital you do not worry about, we are just telling that it is overlapping, that is what we are trying to understand here, just the concept, not the specifics. Okay. So, this is what you will have, there is a nice overlapping in between the atoms. So, here what you do, again the same definition, you take the centers of the two atoms which are what? Bound by covalent bond. And what kind of covalent bond? It is bound by something called as a single bond. Single bond means only 2 electrons are shared. Okay? Only 2 electrons are shared. 2 electrons are shared. You take the distance in between this, and then you divide the distance by 2. So, for covalent radius, whatever is the distance here, this distance will be divided by 2. Okay. Now, imagine this is chlorine and chlorine. The distance in between this is found out to be 198 picometers. So, how will I get the covalent radius here? Covalent radius will be 198 divided by 2. So, what is the covalent radius? The covalent radius for chlorine is 99 picometer. What is it called as? It is obtained as 99 picometer. So, this is something that you have. Now, imagine chlorine, imagine, because it cannot do that, but imagine chlorine forms metallic bond. Will the metallic radius be larger or smaller than the covalent radius? Think about it. See, chlorine means it should first come and touch one another for metals, whereas for covalent it should overlap. So, what will happen? Covalent radius will be less because the atoms are coming closer. But remember, when you are writing the definition, this word should be there, single bond, because covalent bond can be single, double, triple. Okay. Again, you will study this in chemical bonding chapter, but what you should know is the bond should be what kind of bond? A single bond only. So, this is something that you have to know as far as definition goes. The same definition, I think it is there in the chapter of in the page of 94. So, what you can do is you can draw this diagram there, beside metallic radius and covalent radius. So, in both of the cases here you will have this distance. Okay, this distance is called as the covalent radius. So, metallic radius for that diagram, okay, where they are in touch with one another, whereas here the covalent radius, they are not, you do not write it as touching, you write it as overlapping. Okay. So, this is what you can draw there. I will give you a minute to do that, you just draw it. Okay. Metallic radius and covalent radius. So, for the same element, I think you can understand if it forms both metallic as well as covalent bond, single covalent bond, okay, that is what will happen. Yes. So, this is what you have as far as covalent radius and metallic radius goes. In both of the cases, if you see, the atoms which I am taking are one and the same. That means, I cannot take HCl. If I take HCl, what will happen? H is a smaller atom and Cl is a larger atom. So, I cannot take half the distance and do it. So, in both of them it should be, whether it is metallic radius or covalent radius, you should specifically take when atoms which are overlapping. In case of covalent bond or in metallic bond, the metal atoms should belong to the same element. That is very, very important, remember that. So, when you are writing the definition, specify all these things. In covalent radius, it should be the same element bound via a covalent bond. How many covalent bond? A single covalent bond. Okay. So, this is what will happen, say, in case of covalent radius. Now, in your study material, there is something called a screening effect next, but I do not do that. I will do van der Waals radius, the third kind, and then we will go back to the screening effect. Okay. So, what I will do is I will take van der Waals. Okay, van der Waals radius. So, how does van der Waals radius work? Now, I will take the example of chlorine only. I will take chlorine molecule, this is Cl and Cl. I will take one more chlorine molecule. You know chlorine exists as Cl2. That means, one Cl can form bond with another Cl only. Can it form bond with one more Cl? No, it is not possible. Cl2 is formed. Now, if I take this and if I solidify it, what will happen? The molecules will come closer. You have studied about the properties of solids. Solids molecules are going to be compact, they are going to be close to one another. So, what will happen in this case is, they will not touch one another, they can't. Why? Because chlorine is surrounded by electrons. Here also chlorine is surrounded by electrons. When they try to come closer, they will repel one another. So, what will happen is, here there will be a electron force of repulsion, or till here the effect will be there. and here also the effect will be there. So, that means they cannot come as close in the previous cases. In case of metallic radius, the atoms are forming a bond. Which bond? Metallic bond. In case of covalent radius, they are forming a bond. What kind of bond? Covalent bond. Here, can they form a bond? They can't. Okay, they are not able to form a bond, but they come close to one another. How do they come close to one another? That is why I specified at the beginning that it should be in which state? It should be in the solid state. They can come as close as possible to one another. Okay, they will not touch in case of metallic bond, they will not overlap in case of like covalent bond, but they will be close to one another like in case of the van der Waals forces, that is there is repulsion there. So, what will happen now? I will take the center here and center here, join that, okay. I get a line, okay. I will get a new distance d, okay. Then this will be divided by 2, same thing. But what will happen? Both are chlorine only, but is the distance in between the chlorine atoms same? No. In this case, the distance in between chlorine atoms is going to be more. Okay. So, what is this distance? See the distance, 360 picometer is the difference. Previously, it was 198 picometer. So, if I want to find van der Waals radius, this should become d by 2 and this will become equal to 360 picometer divided by 2, which is 180. Now, this is where you have to remember that chlorine has 2 radius. How is it possible? It is possible because of how you measured it. In the first case, covalent radius case, you took atoms wherein they are overlapping. Here, the atoms are not overlapping, they have just come close to one another. That is it. Okay. So, that is the difference that we have in case of covalent radius and van der Waals radius. So, chlorine has how many radius now? 2. You made like for a circle it has only 1 radius, for a sphere it has 1 radius, correct. But here it is because of the way you measure. So, whenever you are specifying the radius, you should not just say atomic radius of chlorine is 99 picometer. What should you say? Covalent radius of chlorine is 99 picometer. Van der Waals radius of chlorine is 180 picometer. Understood what I am telling? So, be very careful when you are talking about atomic radius. It depends on the way in which you measure the radius, that is what matters. So, if an element has all 3 radius, that is it has metallic, covalent and van der Waals radius, then van der Waals radius is greater than metallic and metallic is greater than covalent. Now, this is there I think at the bottom of page number 95, note or put a underline for that, very important, 1 mark question may be asked. But I hope you understood why that is the case, why van der Waals, because van der Waals they come close, whereas in metallic they touch, in covalent they overlap. So, the closer they come, the distance will become shorter. So, all of these we are doing are approximation. Now, you may feel, sir, then what is the use of doing this? Remember, for all we are doing the same thing. Now, if I take chlorine, bromine, iodine, all have covalent bond. In all case, I am doing the same thing, no. So, whatever roughness we get in that measurement for atomic radius does not matter, because we are comparing similar things. But if I take chlorine by covalent radius and bromine by van der Waals radius, I can't compare them. Why can't I compare them? The reason is because they are different kind of radius. Okay, so, be very careful when you are writing about the radius. If you say 99 picometer, that is what kind of radius? That is called as the covalent radius, whereas this is called as the van der Waals radius. You can draw this diagram in page number 95. Okay, at the bottom there is something called as van der Waals radius. You just understand what is this I have drawn here. This is the electrons force of repulsion. They will not allow them to come closer. So, till that distance they can come, after that repulsion becomes more. So, this distance will be more than the previous one. Okay. You can draw this diagram. So, when you see this diagram itself, you will understand overlapping, touching and close, coming close, that is it. Okay. Yes, I hope just draw that. I will erase the other things. Okay. Next, we will go for shielding effect. Now, what exactly is shielding effect? Now, let me just take sodium again. Electronic configuration is 1s2, 2s2, 2p6, then you have 3s1. So, this is the electronic configuration of sodium. So, if I take sodium now, this is going to be my nucleus. Okay, it has 11 protons. Then what I will do is I will take this one. This is my first shell. First shell is going to be 1s2. So, how many electrons can I write? I can write 2 electrons. I will put electron here somewhere. It can be anywhere, electron and electron. Now, I will take the second shell. Okay, do not worry about the shape. It is somewhere here in this region. So, what is the second shell? 2s2, 2p6. So, what do you have here? Electron, electron. How many electrons? Okay, so you have this one, and then finally you have one more electron here, 3s1. Now, the nucleus is positively charged, whereas electrons are negatively charged. So, what will happen? There will be a force of attraction. Will the outermost electron experience the same force is the question. Will the outermost electron experience the same force of attraction? That is not possible by all of them. 11 protons are there. Why? Because there are electrons in the middle. Now, if I take this electron, the outermost electron, it will not experience the full force of attraction because of the nucleus, because the inner electrons are shielding it. Shielding means what? Covering it. Okay? Think about it like this. You are sitting in the class, your teacher is in front of you. If the teacher is seeing you, you will not be able to do any mischief. But what if there is a screen in between us, that is a teacher and student? Even though I am behind the screen and I tell you, students, do not do any mischief, you will be able to do it whatever you want. Why? Because there is no much control on you. The same thing goes here. The nucleus will not be able to control the outermost electron because of the shielding of the inner electrons. Okay? It shields it. So, the outermost electron will not experience the full force of attraction. Okay? So, this nucleus has a charge. What is the charge called? Nuclear charge. That charge cannot be experienced completely. So, that charge now becomes effective nuclear charge. So, can it experience the full force of attraction now? No. Reason is because of the electrons which are inside. So, more the electrons which are there inside, you can expect that the shielding effect goes on increasing. Think about it, the shielding increases. What did I say? A screen in front of me. Okay. What if the screen has a hole in it? Then I can see some of you in the class. So, I can at least control some of them. What if there are 2 holes in the screen? 3, 4, what will happen? I can see more and more of the class and my control will become more. So, think about it now. What is the shape of s orbital? It is a sphere. It completely surrounds the nucleus. So, it is very good at shielding. So, if it is spherical in shape, then the outer electrons will be shielded very well. Understand this. This is not shielding. The outer electron is not shielding. The inner electrons are shielding. So, if inner electrons are s orbital electron, they will shield the best. P orbitals are shielded less, or they shield less. D orbitals shield even less because they are not spherical. Okay? And F orbital are very bad at shielding. Okay? Understand this. S orbitals completely cover the nucleus, so they are very good at shielding. P orbital are not that as good as S, D orbital are not as good as P, and F orbital is the least. So, when I go for shielding effect, S orbital is the best, F orbital is the worst. So, what will happen if it shields well? Then nucleus, so this is shielding, nucleus cannot attract the outermost electron very easily. Okay? It will not attract the outermost electron very easily. So, this effect is called as shielding effect. The definition is there in page number 95. Please memorize that. Okay? So, this is what you call as shielding effect. What will happen to the shielding effect as you go across the period and down the group? That is what we have to understand now. Okay? Yes. So, if I go across the period, sodium, magnesium, aluminium, after aluminium you have silicon, then you have phosphorus, sulfur, and then chlorine. Noble gases, let us not worry about that now. So, sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. So, what will happen? Let me take the nucleus. Now, this one, in between you have 1s, 2s and 2p, that is same for all of them. What changes? For sodium, you have only 1 electron here, 1 more electron adds to the nucleus. For magnesium, how many electrons? 2 electrons, it is added to the same shell in the same region, whereas 1 more proton is added into the nucleus. So, what will happen in this case is that in case of sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine, the shielding effect will remain same itself, you can say, and because of this the nucleus can attract the electrons more easily. The nucleus protons are increasing, electrons are not moving any away from it. So, what will happen? The force of attraction will increase, and because of this the size of the atom will become less. So, what will happen? See, sodium to magnesium, magnesium to aluminium, the shell to which it is added is third shell. So, as and when it is added, the distance from the nucleus remains almost same. The inner electrons are not changing, but the distance from the nucleus and electrons are almost same. The number of protons, the positive charge in the nucleus will increase. So, what will happen to the force of attraction? The force of attraction will also increase. So, what will happen? The electrons will come closer because it can attract more strongly. Okay. So, what will happen because of that? When you go from sodium to magnesium, magnesium to aluminium, aluminium to silicon, phosphorus, sulfur, chlorine, the electrons will come closer and closer and closer and closer and closer to one another. So, what will happen there? This will basically, the size, atomic radius goes on decreasing in case of moving across the period. Remember this, atomic radius decreases when we move across the period. When you go down the group, what will happen is the question. When you go down the group, think about it, you have sodium, potassium, rubidium and cesium. Now, in case of sodium, what is the outermost shell? 3s1, 4s1, 5s1, 6s1. Now, look at this, what is different? Principal quantum number is different. What have you studied about principal quantum number? As the principal quantum number increases, the size of the orbital also goes on increasing. So, these are all what orbitals? These are s orbitals. S orbitals are all spherical in shape. Shape will not change. Size of the orbital will change. Size means what here? It is the distance from the nucleus. So, if I take nucleus, you have 3s, you have 4s. So, what is happening? The distance from the nucleus is increasing. Now, you may feel that there are more electrons inside, but again there are two factors, distance also matters. Okay. More electrons inside means what will happen? Shielding will become more compared to before. No, shielding will become slightly less. Okay, that is because the distance is also increasing. We are not thinking about the distance factor also. So, remember, in case of the across the period, what did I say? Distance remains almost same because it belongs to the same shell, 3s1, 3s2, 3p1, 3p2, 3p3, like that. So, the distance from the nucleus will remain same, force of attraction will increase, size of the atom, radius of the atom will decrease. But what about here? Here the principal quantum number has increased, distance of the electrons from the nucleus has increased. So, already the distance is more. So, what will happen when you go down the group? When you go down the group, the atomic radius should increase. This is given as give reason in page number 95. So, they have given variation of atomic radius across a period and variation of atomic radii down the group. Mark it as important. Okay. This can be asked as a 1 mark question or a 2 mark question. How 1 mark question? They can ask you, how does atomic radii vary across the period? When they ask this, they have asked you how. So, when they ask you how, you have to just say it decreases over. 2 mark question they can ask you, how does atomic radii change across the period? Give reason. So, 1 mark will be there for telling how it varies and the second mark goes for the reason. You have to tell the exact reason. It is there here, please mark it. Okay. Remember, 1 mark or a 2 mark, here you do not get very big questions from this chapter, you get small give reason questions, but students do mistake when they are writing the answer. So, please mark this as important. Clear, students? Now, I have given you the example of sodium, potassium, rubidium, cesium. What if I ask you for magnesium, strontium, calcium, barium? I will give this order, but see, you know that this all belongs to the same group. So, what should I do? I should take the order first. First element comes, so this is why your knowledge of periodic table along the group is also important. So, magnesium, after magnesium strontium does not come, after magnesium you get calcium, then you get strontium and then you get barium. Do not always expect us to give it to you in the order, sometimes we may mess up the order and give. So, you have to first write it in the order, then think about this. Okay. magnesium, calcium, strontium, barium belong to the same group. Okay, that means its electronic configuration is same, or similar would be the proper one, not same, similar. The principal quantum number remains or changes, increases by 1. So, as it increases, the distance of the electron, so it is the same reason, from the nucleus will increase. As the distance increases, the atomic radius also increases, done. Okay. Shielding effect will decrease slightly, okay, negligibly it will decrease. So, that is what will happen, but so that does not matter here. Why? Because the distance has already increased. So, this is what will happen, say, in case of down the group and across the period. Students, please know this, clear. Now, are there exceptions? Yes, there are exceptions, but that you will be, as I told you, taught in the coming chapters. You do not have to worry about that now. Now, you have to remember the general case. Okay, general case is this. So, we now have one more property which we can understand, like your metallic nature down the group, across the period. So, you have to remember this. Generally, atomic radius increases down the group, decreases across the period. So, this is what you have to know. There is an assignment question there, write it down. I have given the answer already in the class. Okay. You just have to write it down, it is there in the give reason only, the same thing you have to do, it is just below in page number 95. That is the exercise question. Next, we go for something called as ionic radius. What exactly is ionic radius? Atomic radius is the radius of an atom. What should be ionic radius? Ionic radius should be the radius of an ion, or we can simply say, if I take the nucleus, the distance up to which the nucleus can exert its force of attraction in the ion. So, the distance up to which it can exert its force of attraction in that ion is called as the ionic radius. Again, 1 mark for definition, clear. Now, let us understand this, think about it, it is quite simple. So, let me just take the example again of sodium only. Sodium has, I will write only this one, outermost electron 3s1. How many protons does sodium have? 11. How many electrons does sodium have? 11. I will remove one electron, only electron I will remove. So, when I remove that electron, I will get protons, I will write it as P, okay. Protons as 11, electrons I have removed, correct. So, what will be the number I get? 10. So, positive charge is one more. So, this ion is called as Na plus. Whenever you remove the electron, you can remove 1, 2, 3, how much ever, what is formed? You get something called as the cation. What is it called as? Cation. When you remove any number of electrons, you get cations. Okay. Now, if I take chlorine, what will I get? I will get 3s2, 3p5. I can add one electron. If I add one electron, I will get 3s2, 3p6. Here the number of electrons and protons are equal to 17. Here protons are 17, proton will not change. Electrons, one more I have done, will be 18, one more. So, what will I write here? I will write it as Cl minus. Understood? So, you have Na, Na plus, Cl, Cl minus. This kind of ions are called as anions. Okay. Again, you can add 1 electron, 2 electrons, 3, 4, 5, you can go on adding any number of electrons. Whether you can do this for not or no, there for oxygen you can add 2 electrons. So, anytime you add electron, what is formed? Anion is formed. Anytime you remove electron, cation is formed. Now, think about this, it is very interesting. Force of attraction 11 protons, okay, 11 electrons, but now electrons have become less, protons are more. So, what will happen? Protons will pull the electrons even more strongly, they will pull them very, very strong, or compared to this it will pull it strong. So, what will happen? The electrons will come closer. So, what can you think? When you remove electrons, the number of protons will remain same, whereas number of electrons will decrease. So, the size of the cation is always smaller than neutral atom. Size of the cation is always smaller than the neutral atom, because you are removing electrons. The nucleus can pull the electrons even more closer. So, effective nuclear charge will increase. Okay? It will increase. The outer electron will experience more force of attraction than before. Here what will happen? Opposite of that. Think about it. Protons are same, but the outer electrons will increase. So, what will happen? They will have a kind of less force of attraction. The effective nuclear charge will decrease, and because of that the size of the ion will be more. And think about this also. Previously there are only 5 electrons and now there are 6 electrons. So, electrons and electrons can also repel one another. So, when they repel one another, they will start moving away. So, this is what will happen. The electrons will come closer to the nucleus in case of cations. So, size will decrease for cations, whereas for anions 2 factors can affect. One is the force of attraction in case of the nucleus will become more, that is effective nuclear charge will increase. At the same time, what can happen is that the force of repulsion will also sorry, I think I told it wrong, the force of attraction will decrease, okay, whereas force of repulsion may increase at times. So, because of this the size of the anion will increase. So, size of the anion increases from its neutral atom and size of the cation decreases. So, this is what you have with the anions and cations. So, please remember which is cation, which is anion, and how the sizes will increase and decrease. Again, give reason is there here, please know this. Now, what about in this case? I will take iron plus, I have removed how many electron? 1 electron. Here how many electrons have I removed? 2 electrons. Here how many electrons have I removed? 3. So, what will happen to the size or the ionic radius? See, is not this the case? Does not it decrease? Why? Because more the number of electrons are removed, force of attraction or the effective nuclear charge will increase, due to which the size of the cation goes on decreasing. Okay? If I take O2 minus, O minus and O, what will happen? I have added 1 electron, so size will increase, added 1 more electron, so size will increase. So, remember, if you take an atom and go on adding electrons, how much ever possible, the size goes on increasing. If you go on removing electrons, the size goes on decreasing. Okay. With this, I will stop the class for today. We will continue in the next class.